Hello, my Linians. This is Teacher Sarah, and today we are going to discuss exponential function. This video tutorial is based from your learning activity sheets in General Mathematics, Quarter 1, Week 5. So bring out your learning activity sheet and turn your learner's module to pages 87 to 94. Our learning targets are: represent real-life situations using exponential functions, and distinguish between exponential function, exponential equation, and exponential inequality. Before the lesson, let us have some warm-up questions. I have some questions for you to answer. Question number 1. Suppose you have a 1 meter long string. When you fold the string into 2 equal parts and then cut at the middle, how many strings of equal length do you have? Time starts now. The answer is 2. Very good. Question number 2. Again, fold each of the string equally and then cut. How many strings of equal length do you have? What do you think is the answer? Timer starts now. Okay. Very good. The correct answer is 4. So our lesson for this session is related in this activity, that when I required you to cut 1 meter string into 2 equal parts, you mix 2, and then when each string again is divided or cut into 2, so you have 4 strings, and then these 4 strings, when you divide it again into 2 equal parts, it's become 16 strings with equal length, and so on and so forth. So this is referred to exponential function. So what is an exponential function? Exponential function occurs in various real-world situations. Exponential functions are used to model real-life situations such as population growth, radioactive decay, carbon dating, growth of an epidemic, loan interest, and investment. So these are the model of an exponential function, which is related in our real-life situation. An exponential function with a base b is a function of the form f of x equals b raised to x or y equals b raised to x, where b greater than 0 and b not equal to 1. Example: complete the table of values for x equals -3, -2, -1, 0, 1, 2, and 3 for the exponential functions y equals 1/3 raised to x, y equals 10 raised to x, and y equals 0.8 raised to x. So given the table, so there are assigned value for x, and then you are required to solve for the 3 given exponential function. Okay, for the given exponential function y equals 1/3 raised to x, you replace the assigned value for x, so it becomes y equals 1/3 raised to -3, and this negative exponent, so you distribute it in fraction 1/3, so that becomes y equals 1 raised to negative 3 and divided by 3 raised to negative 3. And to simplify, you make your exponent positive, so you may change the location of this negative. Like for example, if 1 raised to negative 3, so you put it in the denominator so that it becomes 1 raised to positive 3, and this 3 raised to negative 3, you put it in the numerator so that the exponent becomes positive. So therefore, y equals 3 raised to the third power over 1 raised to the third power. Then simplify, y equals 3 to the third power over 1 to the third power equals to 1. So therefore, y equals 3 to the third power. Then to express it in simplest form, that becomes y equal to 27. So if y equals 1/3 raised to x, to get a value where x is negative 3 is 27. And then if you apply it also to the other assigned value of x, such as negative 3, negative 2, so it becomes 9, y equals 9. Then if x is negative 1, so this becomes 3, and so on and so forth. So using other example of exponential function, y equals 10 raised to x. If x equals negative 3, so we have y equals 10 raised to negative 3. Then again, simplify. Your exponent is negative, so y equals 1 raised to 10 raised to the third power. So your y equals 1 over 1000. Then if you use other assigned value for x, such as negative 2, that becomes y equals 10 raised to negative 2. And then to simplify, make your exponent positive, that becomes y equals 1 over 10 raised to the second power, or simply y equals 100. Same with other value. If x equals negative 1, so y equals 1 over 10. And if x is 0, that becomes 10 raised to 0. Then applying the law of exponent, any number raising to a power of 0, that is equivalent to 1. Then if x is 1, 10 raised to 1, so again y equals 10 raised to 1, so that is equivalent to the base, y equals 10. Then if x equals 2, y equals 10 to the second power, so that becomes y equals 100. If y equals 10 to the third power, y equals 1000. And then using other example of exponential function where y equals 0.8 raised to x. If x is negative 3, so y equals 0.8 raised to negative 3, and then simplify, makes the exponent negative a positive, so that becomes y equals 1 over 0.8 to the third power, or y equals 1.953125. And if you do this in other assigned value for x, so simply, so just refer to the given table. Okay, so finally, so these are the equivalent value if x, using the assigned value of x for the following exponential function, such as y equals 1/3 raised to x. So these are the values: 27, 9, 3, 1, 1/3, 1 over 9, 1 over 27. For y equals 10 raised to x, using the assigned value for x, so these are the value, 1 over 1000, 1 over 100, and so on and so forth. And for y equals 0.8 raised to x, so these are the value using the assigned value for x, such as 1.953125, 1.5625, and so on and so forth. So what do you observe in the values? So as x increases, for y equals 1/3 raised to x, the value of the exponential function decreases. If the given exponential function y equals 10 raised to x, so if the value of x increases, the exponential function y equals 10 raised to x increases also. While if y equals 0.8 raised to x, as x increases, value of the given exponential function decreases also. Okay, so just observe the table. Example number 2, if f of x equals 3 raised to x, evaluate f of 2, f of negative 2, f of negative 1, f of 0.4, and f of pi. So if x is 2, replace 2 to x, so f of 2 equals 3 to the second power equals 9. For f of negative 2, you replace negative 2x, so equals 3 raised to negative 2. Then applying the rule or the law of exponent, you make your negative exponent positive, so that is equal to 1 over 3 to the second power, or that is equal to 1 over 9. And for f of 1/2, replace 1/2 to x equals 3 raised to 1/2, then convert or change to radical form. So your numerator becomes the exponent of the radicand, and the denominator becomes the root or the nth root of the radical sign, so that it becomes square root of 3. Therefore, f of 1/2 equals square root of 3. And then for f of 0.4, replace 0.4 to x, so equals 3 raised to 0.4, and then the exponent decimal 0.4, change to fraction, so that becomes 2 over 5. So therefore, f of 0.4 equals 3 raised to 2 over 5, again change to radical form, so the exponent becomes 2, that is the numerator, that becomes the exponent of the radicand, and the denominator becomes the root of the radical symbol. So therefore, 3 raised to 2 over 5 equals fifth root of 3 to the second power, or fifth root of 9. For f of pi, so since pi equals 3.14159 and so on is irrational, the rules for rational exponent are not applicable. We define 3 raised to 5 using rational numbers. F of pi equals 3 raised to 5 can be approximated by 3 raised to 3.14. A better approximation is 3 raised to 3.14159. Intuitively, one can obtain any level of accuracy for 3 raised to pi by considering sufficiently more decimal places of pi. Mathematically, it can be proved that these approximations approach a unique value which we define to be 3 raised to 5. So let B a positive number not equal to 1. So because in exponential function, it is stated that B is greater than 0 but B not equal to 1. A transformation of an exponential function with base B is a function of the form g of x equals ab raised to x minus c plus b, where a, c, and b are real numbers. Some of the most common applications in real life of exponential function are their transformations are population growth, exponential decay, and compound interest. For population, on several instances, scientists will start with a certain number of bacteria or animal and watch how the population grows. For example, if the population doubles every 3 days, this can be represented as exponential function. So let t time in days. At t equals 0, there were initially 20 bacteria. Suppose that the bacteria doubles every 100 hours. Give an exponential model for the bacteria as a function of time. Initially, at t equals 0, the number of bacteria is 20. And at t equals 100, number of bacteria becomes double, 20 times 2. At t equals 200, number of bacteria becomes 20 times 2 raised to the second power. At t equals 300, number of bacteria is 20 times 2 raised to the third power. And at t equals 400, number of bacteria becomes 20 times 2 raised to the fourth power. So an exponential model for this equation is y equals 20 times 2 raised to t over 100. Suppose a quantity y doubles every t units of time. If y sub o is the initial amount, then the quantity y after t units of time is given by y equals y sub o multiplied by 2 raised to t over t. For exponential decay, exponential function can be used to model radioactive decay. The half-life of a radioactive substance is the time it takes for half of the substance to decay. Suppose the half-life of a certain radioactive substances is 10 days and there are 10 grams initially. Determine the amount of substance remaining after 30 days. Let t time in days. We use the fact that the mass is halved every 10 days. That is from definition of half-life. Then, or thus we have initially at 10 equals 0, the amount of substances is 10 grams. At 10 equals 10 days, the amount of substances is 5 grams. At 10 equals 20 days, amount of substances is 2.5 grams. And at t equals 30 days, amount of substances is 1.25 grams. An exponential model for this equation is y equals 10 multiplied by 1/2 raised to t over 10. Another common application of exponential function in real life is the compound interest. A starting money, called the principal, can be invested at certain interest rate that is earned at the end of a given period of time, such as 1 year. If the interest rate is compounded, the interest earned at the end of the period is added to the principal, and this new amount will earn interest in the next period. The same process is repeated for each succeeding period. The interest previously earned will also earn interest in the next period. So we can defend this discussion in our next lesson, in the next chapter. So let's have an example. Mrs. De La Cruz invested 100,000 pesos in a company that offers 6% interest compounded annually. How much will this investment be worth at the end of each year for the next 5 years? So initially, at T equals 0, the investment is 100,000 pesos. And at T equals 1 year, investment becomes 106,000 pesos. And for T equals 2 years, investment becomes 112,000 pesos, 260. At T equals 3 years, becomes 119,101.60. And at T equals 4 years, investment becomes 126,247.70. And at T equals 5 years, the investment becomes 133,822.56. So in this exponential model, in this equation, our A equals 100,000 multiplied by 1.06 raised to T, or T is referred to number of years. So if a principal P is invested at an annual rate of R compounded annually, then the amount after T years is given by A equals P multiplied by 1 plus R raised to T, where A is the amount while P is the principal, and R is the rate of interest, and T is the time or the number of years. So another application is the natural exponential function. The natural exponential function is the function f of x equals e raised to x. So exponential function may have various bases. A frequently used base is the irrational number e equals 2.71824. So that is an irrational number. Because e is a commonly used base, the natural exponential function is defined having e as the base. Example: a large slab of meat is taken from the refrigerator and placed in a preheated oven. The temperature T of the slab T minutes after being placed in the oven is given by T equals 170,165 e raised to 0.006 T in degrees Celsius. So construct a table of values for the following values of T, such as 0, 10, 20, 30, 40, 50, and 60. And then interpret your result. Round up to the nearest integer. So the solution is as follows. So you observe the table. So the slab of meat is increasing in temperature at roughly the same rate. Next, let's move to the differences between the exponential function, equation, and inequalities. An exponential expression is an expression of the form a times b raised to x minus c plus d, where b is greater than 0 and b not equal to 1. So to distinguish exponential equation, inequalities, and function, so the table shown below. So for exponential equation, this is an equation involving exponential expression. An example, we have 7 raised to 2x minus x squared equals 1 over 343. For exponential inequality, this is an inequality involving exponential expression. For example, 5 raised to 2x minus 5 raised to x plus 1 less than or equal to 0. And for function, exponential function of the form f of x equals b raised to x, where b greater than 0 and b not equal to 0. For example, f of x equals 1.8 raised to x, or f of x is y, so therefore y equals 1.8 raised to x. So an exponential equation or inequality can be solved for all x values that satisfy the equation or inequality, while an exponential function expresses a relationship between two variables such as x and y, and can be represented by a table of values or graph. So that's the end of our session on exponential functions. So if you have no question regarding the lesson, so let's do your activity. Turn your activity sheet in enrichment part to do your task. For enrichment number 1, you determine whether the given is an exponential function, an exponential equation, an exponential inequality, or none of these. I'll give you 1 point for each item. Please do not write anything on this answer sheet. Write your answer on a separate long bond paper. Activity or enrichment activity 2, multiple choice. You choose the letter of the correct answer and write it on your answer sheet. Again, 1 point in each item. And for enrichment activity 3, you solve the following problems. Show your solution and write your answer on your answer sheet. Each item gives you 5 points. Okay, for wrap-up activity, you answer the following questions and you are required to answer this part. So this gives you a bonus point or additional 5 points in your score in enrichment activity. I hope you learned something today. If you have questions or clarifications regarding the topic we discussed, feel free to contact your subject teacher through text, call, or post your questions in your official Facebook group or page. Thank you for watching. Don't forget to like and subscribe. Bye!